Okay, so here is that pseudostratified ciliated columnar. This is going to be in the trachea, the bronchi, and it gets shorter in the bronchioles, and it goes down to just a simple squamous in the alveoli. Okay, and you can see those cilia on top there. You can also see there are what are called seromucosal glands underneath it. Those are going to provide a mucousy, serous-y kind of fluid that'll coat the respiratory tract and protect it. Okay? And you can see the island cartilage underneath. I won't show you a picture in the test, okay? I just want you to know that we've got that pseudostratified ciliated columnar, okay? That'll help to filter substances out. Okay? So bronchi, trachea branches into right and left. These branch into secondary, then tertiary, okay? Right secondary bronchi have 3 branches because there are 3 lobes, okay? Left has 2 branches because there are 2 lobes, and it eventually gets down to 10 subdivisions that you've probably learned clinically, I would think, right? Bronchioles are going to be the smallest. They lack that cartilage once again, but they have that smooth muscle, and that allows areas. Well, the whole purpose of that smooth muscle, guys, is to direct air into areas that are highly oxygenated. So if we are not breathing deeply enough, or if for some reason there's a little mucus in one area or blockage, you know, small blockage, obviously, not a big one, in one area, our body senses that, and we can bronchoconstrict that area and route air, you know, well, actually, that would be with the capillary side. I'm sorry. We can change bronchial constriction from one area to another if we need to, you know, route around a different area, or if we have an irritation in one area. Okay, so those bronchioles can help with that. But the bronchioles overall will help with either letting more air in or closing down a little bit. So if you go into what's called sympathetic facilitation, that's that whole fight or flight thing with the bear, okay? Your bronchioles will open and they allow more air to come in because we'll be utilizing more air. If you're in a resting state, the bronchioles will close down a little bit because you don't need as much air for energy, okay? So, bronchi help to warm and filter the air. We talked about that, okay? Now, I do have extra copies. They're right here. So, let's talk about smoking. I hope none of you smoke, and if you do, I hope this helps you to stop this lecture. Because what will happen with the beginning of smoking is, first of all, it will paralyze the cilia. Okay? So cilia have this nice motility or ability to move, to filter substances out. First thing that happens is they paralyze them. Smoking paralyzes them. The second thing that happens is it will actually destroy them, and they will start to move away from that columnar shape into more of a squamous, amorphous shape. So you start to get that metaplasia that we talked about, you know, way back when, the beginning of the course. That's not good, okay? There's a reason that it's columnar shaped, okay? There's a reason we have cilia. So that gets destroyed, and smokers get that really funky smoker's cough, okay, where they can't. My great aunts had it. Of course, it kills me. A little side note here. My great aunts lived a long, healthy life. They both made it into their mid-90s. Both of them ate Twinkies for breakfast, whiskey for dinner, and smoked all day long. I don't know how they would have lived to 120, right? And both of them, you know, we'd go to visit. My mom and I would have like gas masks on when we go to visit because their house was just, you know, needed to be fumigated. And they would just sit there and smoke and hack in half and smoke and hack and hack, you know. The one was on oxygen. She's still like smoking. I'm like, oh my God, we're going to get blown up. But that's right. Exactly. Smoking out of her trach. So they don't have the cilia. The cilia is not there to get rid of all that junk. So the only way, you know, if you start to get mucus that settles down, or substance or particulate matter that settles down into the alveoli reflexively don't like that. And you start to, or any of those passageways, you'll start to cough to try to get it up and out. Okay. They get that hacky smoker's cough. God bless them. My great aunts, they were fun. Okay, we know this. Right has 3, left has 2. Located in the thoracic cavity on top of the diaphragm. Diaphragm is going to be the primary muscle of respiration. Okay, and I'll explain to you that mechanism of how it works. It's encased in those pleural membranes. Those pleural membranes are super important to remember. Okay, 2 layers, one on the lung itself, one on the chest wall. Okay. You know what? I think I'd like to review that. Are you guys good with pleural membranes, or should I review it? A review would be good? Okay. I never know quite how far to take it. So with those pleural membranes, because you know, a lot of this is going to contribute to a lot of the dysfunction of the lungs, those pleural membranes. So we have the lungs themselves. Okay, I'm just going to draw one. That looks so bad. Okay, let me draw it bigger too for people at home. Okay, that doesn't look any better, but anyway, on the surface of the lung itself is what is called visceral pleura. Okay, visceral pleura. So the visceral pleura is going to be a layer of simple squamous cells. You don't need to remember that. On a basement membrane, okay? It's going to be a layer on the lung itself. So if I were to open up my chest cavity, take off the first pleural layer itself, and touch the lung surface itself, it has visceral pleura on it. Okay, it's a serous membrane, and serous membranes are going to release serous fluid to decrease friction. If I open my chest plate and you look inside it and I put my finger on the wall itself, it's going to be parietal pleura. But if I close that chest cavity, the parietal pleura does what? Touches the visceral pleura. Okay, very important concept. So just touching with a very thin layer of serous fluid, we're going to have the parietal pleura. Okay. Okay, just a thin membrane of serous fluid between them, we're going to have the parietal pleura. So it's basically a double-layered membrane, isn't it? Okay, it's basically a double-layered membrane that touches each other. This is going to be important to understand because this is what helps to keep the lungs open. Okay, you know, I'll get into the specifics of that in a couple minutes. Okay, so general shape of the lungs. So here we go, little picture if you need a refresher. Okay, different lobes. The trachea, the breakdown to the primary, secondary, and tertiary bronchi. Okay, alveoli are going to, oh, people at home, let me bring in. Okay, alveoli are going to be the clusters of grapes on a stem. They're going to be simple squamous, which means one cell layer thick. They're going to be surrounded by pulmonary capillaries, okay? And they're also going to have surfactant. And I'm sure this sounds familiar when you think about infants, right? Surfactants actually help to break up the attraction of water molecules to themselves. And by doing that, it's almost like a detergent, okay? It's part of what detergents do. They break that attachment of water molecules. So when there's that residual water in the lungs, that water doesn't get attracted to itself and pull the alveoli in, okay? So surfactant breaks that attachment of water molecules to themselves and helps to keep the alveoli open, okay? Reduces surface tension, if that makes it a little bit easier for you to understand. Reduces surface tension in the alveoli. So infants born too young who don't have the proper amounts of surfactant, okay, they can't keep their alveoli open. They have to be put on a ventilator and given artificial surfactant, or I think they can get it from cows as well. I think there's a chemical derived. I could be wrong with that. I want to see there's a bovine source. I think I read that somewhere. Anywho, so, but they've got to be given that, okay? They got to be tested for it before birth and then given that. We know that, I believe. 300 million in the lungs. Isn't that amazing for alveoli? That we have 300 million of something in our body. So cool. Okay, so here we go. We talked about this. Infant respiratory distress syndrome. Okay, a sinus is going to be the functional unit of the lung. Okay, it's going to be a little subdivision, okay, of the alveoli at these terminal bronchioles, okay? It's the respiratory bronchioles. So there's bronchioles that are not included in respiration, okay? And then there are ones that are called respiratory bronchioles that actually can let a little bit of the air transmit across its membranes to the pulmonary capillaries, okay? So 3 to 5 acini are supported by thin sheets of connective tissue known as a lobule, okay? So sinus, little functional unit of the lung, where we get the actual transmission of gases across. The different type of alveolar cells. So if we think of an alveoli, there's going to be 3 main different types of cells in there, okay? Alveolar, and I have a picture of this. Alveolar 1 cells, your book called it something else. I'm going to go with alveolar cells, and I cannot remember for the life of me. Pulmonary, well, anyway, we're going to go with alveolar cells. I think it's a more common terminology. Okay, alveolar 1 cells are going to be those squamous cells that will line the alveoli, that form the actual structure of the alveoli itself. Interspersed between those cells are alveolar 2 cells, which are going to produce surfactant. Okay? Once again, you don't need to know what they look like, just theoretically you need to understand. Okay, and then an alveolar macrophage is going to be part of the immune system, part of the front line of defense against infectious agents. If you think about it, we need something right there, right? How many bacteria and viruses are we inhaling? Especially you guys, where you live, and me with 4 kids. We're all infected, right? It's another front line of defense if you inhale any sort of antigen. We've got macrophages right there waiting to ingest them and get rid of them. Okay. And it can also work on substances that have gotten into the alveoli, excess mucus fluid, dead cell parts, whatever. Okay. Let's see. Oh, here's a good picture of it. There's 2 things. So I want you to look at the alveolar cells here. And you can see it says squamous, and squamous is that egg shape that we talked about before. And it's almost like you're looking at that squamous cell on edge. So if I were to break an egg and you were to get down at the counter level and look at that egg on its side, can you imagine that that's what that little alveolar 1 cell looks like from the side? Okay. So we've got those alveolar 1 cells. I don't know if they have any alveolar 2 cells. I don't care if you know what they look like. We also have those, the great alveolar cells, or those macrophages. Or I'm sorry, not the great alveolar cells, the alveolar macrophages, sorry. But you can see right there, the capillary is right next to it, okay? And that also is a simple squamous, okay? And you can see the red blood cells that are in there. The red blood cells stay in that capillary, and gases are exchanged between the alveoli and that capillary, okay? The red blood cell stays in there. It's just the gas that crosses over. You can see how there's only one membrane between them, or one what's called basement membrane, okay? Altogether, it's called the respiratory membrane, because we've got the alveolar cell, we've got the squamous cell on that capillary, and then we've got a thin layer of connective tissue, a loose connective tissue between them, okay? So it provides the ability for quick exchange, quick, easy exchange, okay? I also want to point out, because we're going to talk about restrictive lung disorders in a little bit, and this is part of what contributes to those restrictive lung disorders, is this connective tissue. It's an elastic connective tissue that can actually get damaged and become scarred and fibrotic. And can you imagine if there's 300 million alveoli, how much connective tissue is in there? It's a lot. So if you get an autoimmune problem, you know, like Goodpasture's disease that destroys that basement membrane, well, it's going to destroy the ability to transmit those gases across. Bad stuff. Okay, bad stuff. Okay. Here's a little bit bigger of a picture of those alveoli, and that's an actual microscopic picture on the left there. They're pretty thin, you know, they're pretty thin. It's pretty amazing they don't get damaged more easily, honestly. Okay. Pulmonary capillaries, let me see how far along I am. So I'm on, good, this would be a good place to take a little breather. Okay, let's go get a cup of coffee, whatever we want to do. I'll put a little music on. I have to use the ladies' room, and I'll be right back. Oh, let's look for this. Let me see if it kept me. Oh, it did. Good. Okay, I'll be right back. Let me stop the tape.